best practices gone bad. This actually, or this whole topic started as a series of posts I was doing on my blog based on some discussions I've had about certain individuals going too far with certain supposed best practices. And I have no idea what triggered the thought of the name, but it just suddenly became, oh yes, this is exactly the way we need to describe it, and I'm going to go with it from there. So we start off with, what are best practices? The dictionary definition is commercial or professional procedures that are accepted or prescribed as being correct or most effective. We're programmers. We don't have accepted or prescribed as being correct. We have, these are the practices that the community pretty much agrees on. Best practices change over time. Even in places where they're prescribed, they change over time. The best practices for building buildings changed an awful lot when we got concrete and steel. Things like that change. So how can best practices go bad? The answer is they don't. Nice and simple. They don't go bad. People misuse them. So why do people misuse best practices? We'll get to that a little bit later. So one of the advantages of having worked in this field for a long time is I generate a long list of really bad examples I can use for things like this. At one company that I was working with, we had a wonderful case of two best practices that fought. In this code base, they wanted to have readable, maintainable code. And like many companies, they decided they would come up with a coding standard to enforce consistency, because they figured that consistent code would be easier to maintain than inconsistent code. By itself, that's fairly reasonable. So the best practices that they started with were expressive long names. I was completely out as a variable for anything. Had to be a longer name. Because we might want to take this Java program and print it out on punch cards, we limited everything to 80 characters. Or either that or people were using DOS terminals. I have no idea. This didn't make any sense, but they wanted 80 character line lengths. Because this was a Java shop, method chaining was also pretty common, because that's a standard practice in the Java community. Now, most of you can probably see that when you put those three things together, badness is going to ensue. Now, in this case, the names have been changed to protect the guilty, but we have an example of what might happen if you were required to have long names, were required to stay within 80 characters, and you did method chaining. This is one expression. And yes, it did take 5 lines. The original was a little messier than this and had names that were at least a little clearer than the stuff that I came up with, so that it didn't give away any information. But I don't know about you, but this is not particularly maintainable. And when one statement becomes a wall of text, it's not very useful. If I had named things the way I would have done it, in this case, well, let's go back to the other one. We had a the business object collection used get item by index to get an item out of it. Whatever object we came back with, we performed action returning in internal object, and then performed an interesting action on that. Business objects get foo, act. That sort of makes sense. I probably wouldn't have used get foo. I would have used something a little more useful, and act is a lousy name, but it's a heck of a lot easier to read than the other one. And lo and behold, that actually fits in 80 characters. But it's a little easier to see what the heck is going on. Now, the fun thing here is you might argue with the 80 character limit thing. Some people are bothered by that, you know. If I'm going to print this stuff out on a dot matrix printer somewhere, it's not going to fit. If I print it off on a laser printer or inkjet, it'll probably work if I've got reasonable fonts. how many people here actually set up their editor as only 80 characters wide, just to make your life miserable? Anybody? No. So 80 characters is a little narrow for a limit, but you could almost make an argument for that. The argument for longer, clear names, that you could say that would sort of make sense, but you put those two together and you get problems. And it fails because the two best practices are both trying to make things more readable, but they're doing it by forcing things in opposite direction. One is trying to keep your lines from running off the end of the screen so you can't see them, and the other one is trying to make every name so long that it's a paragraph, not a single statement. In fact, in a lot of cases in that code base, you had what were or sentences as variable or method names, and it was really hard to read.
Where did the 80 column rule come from? Was that language or?
It was a Java program, so it wasn't language. That was part of the coding standards at the place that I was working. Now, the most fun part about this was as soon as the group realized that these two best practices were fighting each other, what would have been the reasonable thing to do?
Change one.
No. They double down. It has to be done this way because that's the coding standard, and if you can't get your code to work that way, it's because you're a bad programmer.
What happens if your description is longer than 80 characters?
Well, everybody made certain to keep it
Oh.
down to usually about 75 characters, so you can get a dot at the beginning and parens at the end. But that was about it. Yeah. Absolutely horrible. But, two somewhat reasonable best practices. I mean, the point that the 80 character limit, 80 characters is too short, but we've seen cases where the line limit was set to something unreasonable, like what, 400, I think it is, which is completely useless. People run off the end of the screen no matter how big the screen is. So, setting a limit sort of makes sense. Setting clear, well-named variables and methods makes sense. But defining them as long didn't work out too terribly well. So the next best practice that I have the most fun with is dry. Pragmatic Programmer the book, The Pragmatic Programmer, Hunt and Thomas came up with the dry principle. And if you look at their actual definition, it's actually useful. So the definition of the dry principle points out that it's knowledge that we're trying not to duplicate. But most people don't read that. They read dry as don't repeat yourself, and therefore it means remove duplication. Remove duplication is not the same thing as dry. But if you didn't read the original definition, who knows? So you end up with two basic problems. You've got overly dry constants. The first one, by the way, is actually an example ported to Perl from a program that I worked on 20 years ago, where we actually had the constant for defined, F-O-U-R. And it was defined that way because somebody had found the literal for in multiple places in the code, and they couldn't find any one name for it because there was different values that are different concepts that actually all had the value of for. So they named it as for. But by the time I had gotten onto the project, 4 had been redefined to 5. So this was just one of those things that just ruins your life from that point onward, because there's no way to make sense out of it. The next one you'll run across in some cases where somebody has defined the defined constants for the months of the year, and I need to set something to noon. Already got a constant, don't want to just put a literal in the code because literals are bad, right? So I'll use constants instead. And the last case, of course, using that differently to come up with the number of months. Of course, there's a minor problem here. By any chance, do you know if that's a 0-based number for December or a 1-based? No way to tell, and it may not be doing what people think it's doing. Great. Wonderful. But it's a constant. It's not a literal. See? So this is a good thing. We also have the wonderful concept of overly dry code. In this case, which is an example taken from somewhere else that I used to work, or at least a modified version of an example of someplace else that I worked, where somebody noticed that there were 4 places in the code where we had a loop that looped over an array, and it's a loop. It's not dry. So what we'll do is we'll put them all in one subroutine and pass in a control variable that tells it which of the 4 things that it's going to do. And if you look at the 4 things here, they're obviously not related in any way whatsoever. But hey, it must be more dry because we only have one loop. JD appears to be thinking here.
Oh, I'm trying to work my brain around this loop.
Well, it's doing 4 separate things. If you look at the which case, okay, we're setting all the, or which 0, it's setting all the items to blank. In the second case, it's reversing the strings.
You're also altering the array as you go.
Yeah.
You could,
Oh, actually, no, because I copied it into add items whenever we came in the first place, and then we return it, see?
you could make this look acceptable and yet retain all its complexity by passing in a code ref for the middle of the form.
Yes, you could. But the person that I'm thinking of didn't do this. And in fact, it didn't just have an if, it was several if statements that did nice and interesting stuff. It wasn't just one little loop. But the general concept still applied. The only thing that was, or the only duplication that was removed was walking over a loop. And that's noise. It's structural. It's not knowledge in any way. And in actuality, if you set this up where you were passing in a code ref, how is that different than map, which already does this sort of thing fairly well? But somebody did this and decided that they had made the code more dry because we only have one loop instead of 4. So we've removed duplication. But we haven't put any knowledge in one place. Now, one other thing that I should have mentioned earlier, when I first ran across the term dry, or the concept of dry, not the term dry, was years and years and years before the Pragmatic Programmer book came out. In a book called Programming on Purpose, PJ Plogger came up with the term the one right place. And in his case, the one right place was not just one unambiguous instantiation of whatever it was you were looking at, but it needed to be in the right place. It's not just that you have only one copy. If you only have one copy and it's in the wrong place, it doesn't do anybody any good. Now, amusingly enough, nobody that I knew of who did or who looked at it as the one right place ever did this sort of thing. It's the fact that the Pragmatic Programmer book specified it as a really simple, easy to understand phrase, don't repeat yourself, and people latched on to repeat and not the knowledge. Problem. So it failed because because the people that do this sort of thing focus on code or text duplication rather than knowledge duplication. And knowledge duplication was the important part. We don't want to have the knowledge in multiple places. The knowledge of how to walk a loop, who cares? The examples we had with the constant December, obviously when you assign December to an hour, you're using the wrong concept. Make a new one. It makes sense. Okay. So the next area of best practices is design patterns. I don't know how many people have run across this recently, but people have been pointing out that the design patterns book that we're all fairly familiar with came out 20 years ago in 1995. Those of us who ran across design patterns when it first came out, if you'd been doing object-oriented programming for a while and you hadn't been doing it for too terribly long, this book was a revelation, sort of. What you found was good solutions to repeated problems. Some of these problems you'd seen before and you went, I've had to solve that. This is what I needed to solve that. Or, you know, I almost did that, and now I know why it was always a problem. So you had a good solution. More importantly, you had good names for the solutions. Today, not 21 years ago, but today, if I tell somebody I'm using an iterator and they're working in object-oriented programming, they're probably going to know what I mean. If I tell them I'm using the decorator pattern, they're probably going to know what I mean. 21 years ago, I've got this object that kind of walks through or allows me to keep up with my places. I'm walking through a container and they'll say, why don't you just use a pointer? There's a concept there that we now have a name for and we can do something with. The next thing the design patterns book gave you was a way of formulating and describing solutions. So their pattern language was useful for defining a problem, a set of forces, consequences, and a set of classes or a set of, they weren't really classes, but concepts that you could apply to make classes out of was a really good way of defining some of these things. A whole bunch of pattern books came after that point. It also gave you at least some idea of how to do good design. It wasn't the best, but it was a good start. Now, unfortunately, we had several things come together at once. Number one, object-oriented programming on the PC was on the rise at that point. We had a brand new language that had just come out that was strongly object-oriented and exceedingly hyped by the language or by the company that created it. And you had a whole bunch of new programmers coming in a field where they could suddenly get paid an awful lot of money for knowing programming. Late 90s. Anybody remember this time? So one of the things you ran across was new programmers that would take this attitude. If you don't have patterns in your design, it's bad. Just period. It's wrong. It has to have patterns or it's not right. This led to the funny examples of Hello World 17 patterns. And if you give me a minute, I think I can get the other 6 in there, but it's going to take a little bit of effort. I saw what would effectively have been a one-page Perl script written in some object-oriented language trying desperately to force all of 23 of the patterns from the design patterns book into that one script. And it was always a nightmare. Since Java was new at this time, they took patterns to heart as well, and sometimes generated interesting things like file input. Input streams in Java make heavy use of the decorator pattern. So I can have a file input stream that attaches to a file. I wrap that in a buffered input stream that does buffering, and I wrap that in a gzip stream that automatically unzips the stream as I read it from disk, and I wrap it in another decorator that converts it into some form of object. Wow, wasn't that great? Now, since we've got patterns for this, of course, they broke it down into very small chunks that you could put together any way you wanted. It did end up with a minor problem that the case that everybody really wanted, a buffered input stream or a buffered output stream, always required you create 2 objects. Because you had to open the file and then wrap it in a buffered object. So the common case required 2 objects, which meant a whole bunch of junior programmers ended up opening files and reading them in a very horribly slow, inefficient fashion. But we got patterns, so it must be good. And then I ran across a joke that pretty much summed up the whole thing. This actually isn't an indictment of Java at all, just of Java programmers. I have a problem. So the first thing I do, of course, is make a problem factory. It's just the right way to solve this. Of course, you probably pass the problem factory to a solution factory so that it can generate solutions for you, but that's another issue altogether. We won't go there. So design patterns by themselves didn't really fail because of anything that was wrong with design patterns. It was that design patterns were intended to help you think about problems. Think about the solutions you would apply to these problems and see how they fit together. But a whole bunch of people said, ooh, I can just take this and spread it on my problems, kind of like I'm spreading on mustard or something, and it'll make things better. This is usually something that you see a lot with junior programmers is they run across a new technology and they just slather it on their code and hope it'll make things better. That definitely happened with design patterns. So the next best practice is a little harder to describe, but I ended up putting a few concepts together into one place. Design. Some of you, I don't know how many people here are actually old enough to remember when the way almost every program out there was done was, if you weren't in a big government organization or a bank or something, you sat down and started banging out code until you got something that basically got to the end. It was the old code and fix approach. You slap a bunch of code in, you try it, see if it works, and if it doesn't, you just move things around and add more stuff and hope that it works. Eventually, most of us learn the concept of design. If I sit down and think about it a little bit ahead of time, I might be able to kill off some of those dead ends. Just pull things back into one path. Maybe not the right path, but at least a little bit better. So the joke that I've seen for years on this is you guys go ahead and start coding and I'll go find out what management wants. If we got no ideas, we're just gonna code it. To fix the code and fix problems, a lot of companies, and the government was also big on this, was the idea of designing everything up front. This is the basic waterfall approach. So we start out, we go and talk to all of our stakeholders, we get all the requirements. Later, we end up training people specifically to get requirements from people so that they can ask all the right questions to get all the requirements. And we take all those requirements and we hand them to some specialists who go in and do the design. And they spend months and months and months on this, and they come up with a design, and they toss it off to some coders, and the coders go off and write it. We all know this doesn't work. Amusingly enough, if you track down the article that first describes the waterfall approach, which I found a few years ago, somebody pointed to it, it actually describes the waterfall approach just the way we've seen it and explains why it doesn't work. This is actually the place where the waterfall approach term was first coined, and it says, don't do this. And people have been doing it for 30, 40 years since then. The biggest problem with big design up front is you're designing when you know the absolute least that you'll ever know about the system. Anything you do from this point on is going to teach you something. So right now, you know the least. Possibly could be a problem. The design is almost always compromised as soon as you start writing code, because we start learning things. UML is one of the great examples of big design up front. It can be used in other ways, but most of the people that I've seen that tend to use UML like to do it up front. They spend lots of time doing circles and arrows and, well, actually squares and arrows and little numbers and stuff. And they finish this all off and they have a picture, and hopefully somebody can convert that picture into something we can run. After a few rounds of doing a whole bunch of design and then trying to implement it and finding out that you didn't know enough to do it right, people get better requirements. Like I said, you try harder and harder and harder, and eventually you reach the wonderful state of analysis paralysis, where we're spending all of our time trying to analyze to make certain that we don't make any mistakes, and we end up not making any mistakes because we don't do anything. That's one way not to make a mistake, but not very useful one. Eventually, people started learning that big design up front doesn't work. So the next approach was to try and identify all the spots in the code where things are going to change, because things change. We know that happens, right? Requirements are going to change. Somebody decides we're going to go for a different database than we were going to go for. So what we do is we pick anything that might change and we make it flexible enough that we can change it on the fly. Unfortunately, this requires predicting the future. How many here are really good at predicting the future? Yeah. Predicting the future is hard. Predicting anything is hard, but predicting the future is particularly hard. This also means that quite often you're going to design for a change that doesn't happen. How many people have seen systems that have very carefully written code that makes certain that you can swap the database out from under it and has never changed databases? Or systems that call out to another web server to get, let's say, weather data. And they don't want to be dependent on the weather channels or weather.com's API. So they make a piece around that and they never change it. So you end up putting a lot of design in for changes that may not ever happen.
Not to mention when they go to change it, they discovered their design wasn't.
Yeah. You'll probably also miss changes that actually do happen. So things that you thought could never possibly change. There's no way in the world that we'll ever have more than 4 gig available. So we need to just be aware of that. So you end up not getting what you want out of that. Reasonable assumptions can fail. There was a really great one that I ran across at one place that I had worked. We had a Linux system that took a half hour to shut down. Every time we shut the system down, it took half an hour. Linux has since been fixed so this doesn't happen. But what happened was the write cache wasn't right through. So when you wrote to disk, it just wrote to the file cache. And then it would flush it whenever you shut down. This was the first 64-bit system we had ever loaded that had plenty of memory. So after working for a while, you ended up with 20, 30 gigabytes of cached file stuff. And when you went to shut down, it took a while to write all that out to disk. The assumption that you'd have plenty of time at shutdown was a fairly reasonable one up until people had way too much memory. So there you go.
So you guys did a sync 30 minutes before shutdown time? Is that how you said it?
Something like that. And then we weren't the first, but we were one of the last of the people who found this out. The Linux kernel developers had been working on it frantically to make certain that they could get it to work right. They ended up with only a small amount of memory that was that was dirty at any point in time. It was fairly obvious once you'd run across it, but anybody here used SOAP? So what's the acronym SOAP stand for?
Simple object something protocol.
When it was created, SOAP stood for Simple Object Access Protocol. Right now, SOAP stands for SOAP. It was never simple, and they finally admitted that. SOAP was designed to be flexible enough to sit on top of any transport protocol. I have heard that people have used it on something besides HTTP, but I haven't actually seen an implementation. It was designed to be flexible enough so that we could send data from between any two operating systems, any two languages. Everything should be supported. So it's so flexible and has so many layers of fun, most people will tend to avoid it. But it's flexible. So the pushback against big design came from the extreme programming group. when the team first started describing, or the team from Chrysler, if I remember correctly, first started describing extreme programming, they came up with the term YAGNI, which the polite version is you aren't going to need it, or you ain't gonna need it, if you prefer to be a little more slangy about it. But the idea is, if you don't actually need it right now, don't code it right now. Seems fairly obvious and straightforward, but lots of people have trouble with this idea. Mostly because I'm in the middle of a piece of code. I just thought of a great thing that I can put in that we might need later. Anybody ever been tempted to do that?
Yeah.
Anybody ever had a point in time when they weren't tempted to do that? So what's YAGNI? It's from the extreme programming. It's do the simplest thing that could possibly work. Now, right off, I'm sure most of you can see that this one line has a potential for fun. We'll get back to that. The goal was to avoid maintenance of code that you don't need. Because once you put the code in there, you have to maintain it, even if it's not really being used for anything. You also get to avoid bugs in the code that wasn't ever needed. Remember that thing about predicting the future? If I decide to put it in now for something that I might need later, what are the odds that I know more now than I will when I need it?
Very good.
Yeah, not so much. And this only works if it will cost more later to implement it. Now, this might make sense. You might actually want to do this if all of your senior people are going to go away next week. You get some smart people putting it together now and then have lesser people working on it later, but that probably never happens. So in general, YAGNI came about to say, let's not put in stuff that we don't need. But we get overload from YAGNI as well. So I don't want to code that. I'm going to invoke YAGNI because I don't think we need to put in a database yet. We can do everything in a text file. If you know that the first run of this code is going to need 1 million records, a text file is never going to be worth it. You're going to need a database. You might as well go ahead and put it in now. That's not avoiding stuff that you need later. It's, I'm going to have this. It's part of the requirements. Deal with it. YAGNI also doesn't say anything about avoiding thinking about the code. It's just avoid writing it. So it's often useful to go in and look at a problem and say, how could this evolve? How could this cause us problems in the future? Okay, well, let's keep an eye on those things and just not change it. We'll keep the simple solution, but we need to be aware that these things may come up. Leave out convenience functions. The Java place I was talking about before with the two best practices that fought against each other. One of the other best practices they came up with was unnecessary code was unnecessary, so don't put it in. This included the concept of convenience functions. I've got 3 things that are usually called as a unit. I don't know about you guys, but I would wrap that in a method and have one to call that always calls them the same way, same order, everything's fine. I was informed by the manager in charge of that group that we will have no convenience in this code. Pretty much summed it up for me. But this was YAGNI taken too far. Even when it was something that would make things less buggy, make less chance of people making mistakes, would make it more robust and over the time we were actually using it, didn't want to put the time in to do that because that was stuff we didn't actually need today. And then it's also possible that you can get a little too simple. Now, XKCD is great for this sort of stuff. This is a wonderful example of YAGNI gone wrong. It's a random number. Probably not what we actually need, but so there we go. So why do those two design best practices, which they've been called best practices at different points in time, why do they fail? Too much upfront design fails because we can't predict the future, and too much Yagni looks like you're putting your head in the sand and just doing code and fix. We have to be somewhere in the middle. And if you look at Yagni as a solution or as how do I want to say it? If you pay too much attention to the term and try to avoid doing all code or any code that you don't need right at this moment, you can make your life miserable and end up with code that's badly designed. And if you spend all of your time doing design, you end up with analysis paralysis and don't get anywhere. So two different best practices that compete there. So now that we've seen a bunch of best practices gone bad, we go back to the question of why do people misapply best practices? This is probably the number one, cargo culting. Somebody else used the practice, I'm going to use it. I have no idea what it means. I have no idea what it does. I don't know why we use it, but doggone it, people said I need to do this, so I'm going to not repeat myself or whatever. Misunderstanding. The whole dry thing is about a misunderstanding. Not paying attention to the fact that it's the knowledge we don't want to repeat, and paying attention to code duplication gets you in the wrong problem. You're misunderstanding what the best practice is about. This one I find the most amusing. Why do we put in best practices? There's several reasons.
Maintainability, everybody speaks a common sort of standard.
Common view of the problem or of the way we're doing development is probably one of the best. Having a common approach so I don't have to think about things that we do the same way all the time. I spend my time thinking about new stuff, not the old stuff.
Prevent common pattern failures.
Right. Which brings me to the part that's the most amusing is for people who don't have much experience, best practices are a good way to kind of keep them out of trouble. You say, this is just the way we do it. Don't worry about it. You'll understand eventually. Unfortunately, people who lack experience are the ones that are very likely to misuse the best practice because they didn't pay attention or because they don't know enough or because they don't look at this and say, wait a minute, I've had this kind of screw up before. And if I use this best practice in the obviously wrong way, it's going to cause me grief. So I'm not going to do that. More senior people are less likely to make that mistake, but there you go. The last one is the most annoying. You're just being lazy or not really thinking, kind of doing the fuzzy thinking thing instead of really careful thinking. That 80 column long variable names thing was a wonderful example of fuzzy thinking. Whoever put together the coding standards just didn't think about how any of the coding standards interacted with each other. Those weren't the only two things that didn't interact well, but they were the two that are most obvious and most amusing. So these are reasons that people misapply best practices. So any questions? Comments? Observations? So I've got some references. The books, Pragmatic Programmer, Design Patterns, and Programming on Purpose, Essays on Software Design are all well worth looking at. This article is really good on the way Yagni should be implemented. Yagni C in this case is clarified. So it's a good one. And this is the series of best practices gone bad that I'm continuing as I run across new and more interesting ones. So if anybody decides they're bored and wants to look at anything else like this that I've commented on, here are some more.
Is that on Anomaly?
Yeah, it's on my Anomaly site.
Or
Yeah. And then just to give you an idea, I've got a lot more, but I didn't want to bore y'all too terribly much with the rest of them. So
What's feature freeze?
Had a company that had a bad problem with scope creep. Things kept running off the end of the deadline. So the idea was, we have a deadline on the 21st. On the 7th, we declare feature freeze. No new features can go into the code. For the next 2 weeks, the only thing allowed to be done are bug fixes.
Is it a bad thing?
This sounds good, right? First time it happens, you get some slop. People don't quite make it, so we let it slide for the first time. The second time we do a release, somebody gets balled out because something that they agreed to do doesn't get done in time. We had a feature freeze, couldn't go any farther, but you need to do it beforehand. But I was working on other things you wanted then. Arguments ensue, things get fun. Third time, all of the features are implemented. In a couple of the cases, we have 3 or 4 subroutines. There's nothing in them. But they're there, the feature exists. They just have this little bug that they're not implemented yet. Feature freeze itself isn't a bad idea. It's how it got misused.
Yeah,
That's gone bad.
But to me, that's not a freeze, that's the deadline. Believe
Well-
it, the deadline means something, you know.
But just like the other best practices, by themselves, the best practices are bad. It's how it got implemented, how it got used, how things worked around it. I mean, the problem with a feature freeze, the problem with feature freeze in the particular place that I'm thinking of is we have our favorite from project management, the iron triangle. You get good, fast, and cheap. If you try to get all 3 of those, you have a problem. You often see people say good, fast, and cheap, pick 2. I normally say pick it at most 2, because you can actually put together a system that gets none of them. Quite often you'll get one that gets 1 of the 3,
The problem,
but you can't get all 3. So if you set a deadline and don't allow the features or don't allow us to cut back on features, it's going to be a problem.
the problem with feature freeze is you're encouraging cramming, which means you're encouraging poor quality.
Well, you can do feature freeze as long as you you allow the scope to change, and you work on the most important features first. And this is pretty much how sprints work, right? We have a deadline. We're not allowed to make it past the end of that. And if we run out of time, some things don't go in.
At another company, it was called change freeze.
Yeah.
And I'm struggling to remember the difference. But change freeze was much more rigid about
Mm-hmm.
what was allowed versus feature freeze, where it's just, well, no new features, but you can introduce bugs, and then we have to have a discussion about what's a bug.
Right.
Yeah,
Um,
and then
Ki-
we have to decide by a committee on what could be
mhm.
past the freeze. and-
So can anybody guess what the company that I'm thinking about did after we ran into this problem?
The feature freeze problem?
Yeah.
Continuous release?
Nope.
No.
We put in another deadline before the feature freeze that everybody called feature slush, which was we can't add new features, but you can finish features during that time. And it just, yeah, it's not quite frozen, but it's kind of slushy, but the same general idea applies. You know, you're still not solving the real problem, which is you want all the features in place, but you want a deadline as well.
Well, and the other problem is integration. I mean, the reason you need the feature freeze but bug fix is because you need the time, the integration time to sort things out.
Well, and
You're actually making an assumption there that they had a good reason for what they did, and that wasn't valid in this case.
To me, it's always seemed like if there is this sort of cramming at the end,
Mhm.
when the deadline happens, then people are they're not working correctly. They should
Yep.
be aiming for the deadline.
Well, the problem is,
That happens?
Well, no, people
The-
do it because they get pushed to do it.
yeah,
But, they shouldn't be pushed to do it. They should
Mhm.
be pushed to work efficiently regardless, you know?
Yeah.
That's quite a chain you gotta go up though to make that clear.
well, in some places that I've worked, when people have seen enough death marches, they begin to realize that, gee, we finish one of these, we get stuff out the door, it's crap, our customers hate it, and we lose developers. which means we need to hire new developers and retrain them. This is expensive. We need to find a better way to do this. Not all the companies I've worked for have been that bright, but a few of them have.
Is that what it takes in the end? It just has to be a bottom line sort of.
Pretty much. Well, what it really boils down to is it's the business that matters. If we don't have business, we don't get paid and we don't get software built. So
I read a great example, like the only companies that actually have hard deadlines, like
Mhm.
let's say we're gonna launch a probe to Pluto
Yeah.
in a year, then that's a hard deadline. We
Mm-hmm.
have to do it. And when they do it, their deadlines are overly reasonable, you know?
Mm-hmm.
They go massively overboard and overestimating how long it's gonna take.
Right. They expect everything that could possibly go wrong will go wrong.
But with
They
these-
look at it and
Yeah, with these sort of nonsensical deadlines that are just made up, like a feature freeze,
mhm.
people are way overly aggressive, trying to make everyone
Yeah.
work overtime.
Well,
So, I mean, Pearl does a feature freeze too, a month out from the expected release. They go into bug fix mode and there's no deadline in bug fix mode. We'll ship it when we've decided it's
Yeah.
ready. And
and
most open source projects.
it can be done.
Yeah.
But once again, the problem with best practices gone bad aren't that the practice is bad by itself. It's that people misuse it. Like I said in the beginning, best practices don't go bad. People use them badly.
I'm actually saying here trying to decide if feature freeze is a good practice. And if it's not, what
What-
is the good practice?
Well, once again, if we say that, a really good example for feature freeze, we have to, before we release the code, we need to have it in place. We need to run it through testing. We need to get it documented. Documentation takes a certain amount of time. So some period of time before we actually release, if we have a release date for some reason, we say any feature that's not finished by feature freeze date, we don't get as a feature. So we can start documenting, we can start planning what we're going to do our marketing campaign for, whatever. The feature freeze itself is not a bad idea. But implemented as, I got the feature done, open curly, close curly, is not a good idea.
Or when you have the feature freeze and, okay, you got it in, you got it in there, got bugs now, and you can't get all of the bugs done by the drop dead date.
Mm-hmm.
You have to take the feature out, then you have to redo all of the testing for it.
Mhm.
Still, if you pass
Well,
the dead date.
The more scary part, which is what I kept seeing, was somebody decides this feature is absolutely critical and we got to have it. It's sort of in. So we throw people at it and we work on it until right up at the release date and send it out the door. And we really haven't had time to test it well enough to know whether or not it's got bugs, which of course means it does. So yeah, we got all the disadvantages of the feature freeze and all the disadvantages of not doing any testing all at once. Wonderful. But like I said, there's lots and lots and lots of best practices that we could play with. Like I said, these are the ones that I'm planning on playing with in the upcoming weeks and such.
Have you invoked monkeys in a cage yet?
Monkeys in
I
a
told you this. Take 10 monkeys, put them in a cage, put banana in the middle of the cage.
oh the water hose.
Well, I was gonna say electrify the floor.
Yeah, I've heard that story before.
Yeah.
Has everybody heard this one?
Okay, so put bananas on the pedestal in the middle of the cage. Anytime a monkey goes for the bananas, you electrocute the cage. Eventually, if the monkey goes for the bananas, all the other monkeys will attack the one going. So then, once you get that behavior down, now you start trading out monkeys. And so now you got a new monkey who's never been electrocuted, and they attack him before the electrocution ever happens. And so you trade them all out till you have a whole set of monkeys, never been electrocuted, but anytime one of them goes for the bananas, they get attacked. And that's the way, that's the way we do things here at this company, and that's how it's gonna be. It's, very often you have standards of the company that nobody ever bothers to question. And, you know, that kind of fits a lot of these slides. I sat there and thought, yeah, it's monkeys in a cage. Nobody said, should we keep doing this?
One of the things that I've pushed at a couple of places that I work is writing down coding standards.
Yeah.
Because you have standards for the company. But if they're not written down, you've got no place to go to erase them when they no longer make sense.
So how do you fix when bad practice has gotten out of hand? My son works for the bank, and he is going through training, taking it from small aggressive companies and trying to apply it to the bank. The problem that he's got is that even if somebody wants the text in a page change, it takes them 3 months to get that done.
Mm-hmm.
You know, so
Well, unfortunately, I only have one. Well, I have a couple of useful bits for that. At one place that I worked, which was actually referenced in here, I won't tell you which one it was, we had a problem with people not following best practices of one kind or another. So I pushed to get some coding standards in place and got a lot of pushback, fought on it, finally got a really simple coding standard in place. And then I suggested one minor change to the coding standards where we would reference another well-known, well-defined coding standard. And everybody said, yeah, sure, why not? Which brought in all the rules that I'd been trying to get them to implement over the few years that I had been there. It's a cheat, but it worked. So that after that, I could say, oh, but in the book, it says, you have to do this. The other example I've got is not one you can do with a bank, but it's one that I ended up doing at second programming job I had. I came into a group that had about 6 programmers, 6 senior guys that had been there for a long time. And over the time that I was there, it grew to about 30. And at one point, my boss decided he was going to make me a manager because he said he wanted to multiply my knowledge. I had been fighting these 6 guys forever trying to get better best practices in place, couldn't make any progress against them. But he said he wanted me to multiply myself, so I went away, came back and said, tell you what, I'll teach all the entry levels how to program in our system. I'll just run normal classes on this. He said, okay. So I started twice a week teaching classes for all the entry level people that we had coming in. And I taught them my best practices. After a couple of years, the guys who had been fighting against the best practices were in the minority, and they had to follow our rules. It took a while, but it did work. Training is the only way I know of to fix bad best practices.
His message is you need to corrupt small children.
Yes. Well, entry-level programmers, but yeah, pretty much. Well, what we had was a group of people that had started when the company had started, and they were cowboy programmers straight across. And trying to get them to follow any practices was, oh, you're stopping me from being creative. It's like, no, I'm trying to stop you from writing crap I have to maintain.
But Wade's change that he made over time as the company grows ends up turning into my son takes 3 hours to get one line change.
It can.
Yeah.
But I actually
Because
wasn't
over
looking.
time, the impact of that change gets bigger and bigger.
Provided, well, that's the other part of it, somebody has to maintain those coding standards. You have to have somebody, usually the senior people in the company eventually reach the point of going, you know, that doesn't make sense anymore. We need to fix that. You know, those rules that we were using when we were Fortran programmers don't make sense anymore. We're not doing Fortran.
Sort of assumes that you understand why the practices were put there to begin with.
One of the things that in a lot of cases that I've worked with, people that really become senior programmers start asking these questions. And those are the people that you want to be able to go, hey, this doesn't make any sense. Does not anybody know why this makes sense? And keep pestering people until you find out either the one guy left who knows why we originally put it in and get it to go away, or we get it to go away because it doesn't make sense anymore. Great example. In a company that I worked at not too terribly long ago, we were not allowed to use strict and warnings. Yeah. And we tried several times to get that backed out. I know there are a few people in the audience here who recognize the story. How did we get strict allowed in the system?
If I remember right, we ran numbers on how much memory it actually ate up, and it was insignificant.
It was non-existent, really. But that didn't fix it. What fixed it was a senior programmer who's standing in front of you all talking to the founder of the company and says, why aren't we allowed to do this? And he said, because of the memory cost. And I said, warnings has a memory cost, strict doesn't. And he said, I've never used one without the other. At which point he agreed strict was fine. It just had never occurred to him to separate the two.
So the argument I've heard against strict was, I don't know the details. Under certain circumstances, the program will crash, not at run at compile time.
There are things that you can do that strict catches at runtime.
Yeah.
Um,
And so those are the ones that are a little problematic.
right, and those are basically symbolic references. Nothing else falls in that category. Actually, I take that back. There are two things: symbolic references and no strict with something that doesn't exist in strict's list. So no strict foo bars will fail at compile time, but that's about it. And when you do that, it actually does increase the memory because it loads carp. Which shouldn't matter because we won't go anywhere at that point. But anyway, but yeah, except for symbolic references, everything else strict does is at compile time, so it's not a big deal.
Is there really a significant memory footprint for the use warnings?
Yeah.
Really?
Not really.
In the compiled case, it does because it loads all of the warning messages into memory at once and keeps them there.
It comes down to what we were talking about before, making a series of short-range
Yeah.
decisions to fix an immediate problem versus fixing the big problem. Big problem, like in our code base, is that it runs the CGI scripts, right?
Well, actually, worse than that, it runs sort of like a CGI script, but it stays in memory forever.
Well, not
Well,
exactly.
not really the execution paths. They fire up and then they go away.
Right.
So they've been over-optimized for the CGI execution style. Whereas like if it was persistent, you wouldn't care about warnings.
The reason you don't want warnings and the reason for the memory that I've always heard is the UTF-8 expense.
I don't know. It's config. It's
There's
config.
some, now,
Yeah.
config you can force it, it's no big deal. But there's some UTF-8 table that Perl CC has to pull in if you use one. So
Yeah. It's mostly a compile thing because if you're not running compiled, the warnings cost is not nearly as significant. But when you compile it, it loads all of this stuff in case it might need it.
So for like regular everyday development, you would be crazy to not use warnings.
Yeah. Well, there's the other thing.
One argument. One argument in favor of not using warnings is that like your runtime code, you don't want it to throw warnings.
Mhm.
So you know it should just keep running in the runtime code. Or at least log it to the safe place and then
Yeah.
send it to the end user.
Which
Yes,
you can make your
it's a
warnings do.
production problem
Yeah.
of- You don't really want to admit that.
Well, they're having those big discussions now about warnings fatal, where there are certain modules on CPAN that if you include them, it automatically kicks your warnings to fatal.
Mhm.
So
JSON access.
Yeah, it wasn't. Yeah, common sense was one that put that. Right.
Oh, common sense does a bunch of horrible things,
But almost
including
nothing
fatal.
uses common sense. Well, that's what serial's for.
you made one point about, I think it's Yagni,
Yagni, yeah.
where you said it only makes sense cost-wise which was it? Like if the cost is higher to build it now?
Well, the idea is that if it costs less now than it will cost later, then Yagni actually, or then not doing Yagni actually makes sense. Because I can do it now cheaper than I can do it later. But that's never happened in the history of software. So Yagni usually makes sense in that line.
I think it does happen. Those are the bits that you build in instinctively.
Yeah. Well, I mean, the purpose of Yagni is for those things that you do not need now, but you will need later.
Yeah.
And if it's going to cost you less now, it's because you probably need it now anyway. And
It's the equivalent of, well, I don't need subroutines for this script. It's very straightforward. And then 1,000 lines later, you're like, well, maybe I should break this up.
Mm-hmm.
Or using flat files to start and then trying to pack them.
Right.
Or the expense of, okay, now I've got support for flat files on several 100,000 servers I don't control. Now the expense of transitioning those servers in a controlled fashion to the new format is going to be non-trivial.
Right. Of course, you can get around some of that by making your flat file CSV, and then DBD CSV works pretty well. But it's still, well, you do that until you convert to a real database, and then problem goes away. But it's still, usually that's not the right solution unless you have no idea what your schema is and you're just playing.
So I think there's a different Yagni calculus for when you control all the places the code runs versus if I sell the software and it's going to be on somebody else's system, but I'm going to have to support them.
Okay. You've worked with Microsoft's MFC, haven't you?
Yeah.
Okay, Yagni would have done them a hell of a lot of good.
Sure.
But they tried to be
From Borland anyway.
No, Borland made the same mistake MFC did first and then fixed it on the second release to screams and hollers from the community.
Yeah, well, I always looked at the cost of doing it now, and besides doing the future, is once when you're in it and writing it, you can probably write a subroutine a lot faster than you come back to in 2 years. Well,
most programmers take that attitude, but once again, 2 years from now, I'm going to know a lot more than I do right now. And it's fairly possible that what I think I know right now is not what it's going to be in 2 years.
But it might not be you, though.
Agreed. But once again,
So to get back to that legacy code.
if I code it in right now and we don't need it, what are the odds that it's going to be in any shape that somebody can use it in 2 years, even if it's not me? But somebody had to maintain it. Somebody had to make sure there were no bugs in it. Somebody had to deal with it, or worse, that code never gets executed. And then 2 years from now, when we need it, all hell breaks loose. Been there, done that. Cleaned up the toxic waste dump that was that piece of code. It's just the whole purpose of Yagni was pointing out that we don't predict very well. Pretty much every time you come up with I know better than I'll know in a couple of years, you turn out not to know as much as you thought you did. Or I can make this happen and it'll only flex these two different ways. So I'm going to set it up to be able to deal with that case. And 2 years from now, we put it in, there's a service I need to deal with that didn't even exist now. No idea. So I got to rip it all out and start over and write it again. Didn't save me any time. So good discussion. Any other comments, observations, opinions?
I'm just unaware of you having had continuous release experience.
At one company that I worked, we had 30 releases in one day.
Okay.
You don't get more continuous than that. The boss went on vacation a couple of weeks after that, and I instituted a rule that we had releases once every 4 business hours. The problem was we were all working in one big directory, so when he did a release, he got everybody's changes, whether they were finished or not. Surprise! That's how we got 30 releases.
If you use a tool like Jenkins and your version control software isn't laid out very well, you could get a lot of, you make one change here and it triggers 30 builds.
No continuous integration software at that point. I had almost gotten the company using version control at that point. I was actually using it on my personal machine. I would log in, grab everything, and push it into version control. I was the only one that was doing it. And testing was whether or not the customer screamed. So this was a ways back. But yes, we literally had 30 releases in one day.
Yeah, if you don't care what the customers think, it's continuous release is the best.
Yeah. So like I said, I've got plenty of best practices that have had fun and planned to chat about. So anything else? Cool.